This is chapter 2 review, number 12, and we're going to be doing parts A, B, and C. Thinks I shouldn't write A quite just yet. All right, let's write down what we know about this scenario here. Starting from rest. Okay, so we have a boat starting from rest. So the initial velocity is 0 meters per second. And the boat speed increases to 6.50 meters per second. So, or the final velocity is 6.5 meters per second. All we know is that it has a constant acceleration, which simply means that our equations will work. And so what's the first thing we want to find out here? Well, A is asking us, what is the boat's average speed? Well, we have an equation for that. We have V average is going to be 1/2 times the initial velocity plus the final velocity. And that is 1/2 times 0 plus 6.5 meters per second. So our average velocity equals 3.25 meters per second. That's part A right there. So part B tells us, and I'll write part B, I'll write it up at the top here. We'll start here. We'll break this up into thirds. Part B tells us even more. We have a change in time of 5 seconds. So we know that our initial velocity, VI, equals 0 meters per second. Our final velocity equals 6.50 meters per second. And our average velocity, VAV, is going to be 3.25 meters per second. If we recall back from the early parts of this chapter, we learned that acceleration, in fact, let me write this down below here. Acceleration is equal to the change in velocity, or that is the change in velocity over change in time. So we could do that, or we could simply write as equation number 1, which is our derived equation number 1, which is final velocity equals initial velocity plus acceleration times time. Either one would work. In fact, this is derived directly from that. So I'm going to use the second one right here, and for part B, we're solving for the acceleration. So to get acceleration by itself, I'm going to subtract VI from both sides. VF minus VI equals acceleration times time, and then divide by T. VF minus VI over T equals our acceleration. And I'm going to write it over here because I'm running out of space on the bottom. What's our final velocity? That's 6.5 meters per second minus our VI, that's minus 0 over our time. That's 5 seconds. And so our acceleration is going to equal 1.3 meters per second, or meters per second squared. That's our acceleration. That's part B. And part C will be in this upper spot right here. Part C, we're being asked, what distance does the boat travel in this time? So the displacement is what we want to know. Well, instead of writing all my givens over again, it's all the same as over here. So we want to find an equation that solves for our displacement. We have a number of things to choose from. We have initial velocity, final velocity, acceleration now, and time. Well, one thing I'm thinking of that we could use is our displacement. This is equation 3 equals 1/2 of initial velocity plus final velocity, which if you think about it, that's really all this right here is really our average velocity. That times time. So let's rewrite this. Delta x is equal to 1/2 times vi 0 plus final velocity 6.5 meters per second times time, which is now 5 seconds. And if we calculate that out, our delta x is going to equal 16.25 meters.